Hello classmates, today we will learn about the part machining process of mold guide pillar. Mold guide parts are the basic parts of molds and typical shaft sleeve parts in mold parts, such as guide pillars, guide sleeves, etc. These parts mainly use machining methods such as turning outer circles and grinding in ordinary mechanical processing. Due to the promotion of standardization of modern mold parts, many parts in mold parts have been standardized, such as the standard series of mold frames, guide pillars, guide sleeves, etc. Batch production can be carried out using dispersed processes, while some non-standard guide pillars and sleeves are still processed using centralized processes. Second, case parts. As shown in the figure, we will take non-standard guide pillar parts as an example to explain the machining of mold shaft parts and the preparation of processed parts. From the part drawings, we can see that the technical requirements for this part for 20 steel, treated with quenching of 58 to 62 Hc and surface carbizing of 0.8 to 1.2 mm. The remaining surface roughness is Ra 6.3 μm. The materials for the guide pillar parts include T8A and T10A, which can be heat treated and quenched to meet the specified hardness requirements. Firstly, we conduct a process analysis on the guide pillar parts. The guide pillar parts are typical shaft parts, and the basic surface of the guide pillar is an outer cylindrical surface. The areas where high precision is required for the guide pillar parts are the outer circle size on the left and is millimeter, which adopts an interference fit of H7 or R6 with a template for installing the guide pillar, and the surface roughness requirement is Ra 0.8. The outer diameter of the right end is millimeter, which is matched with the gap of H7 or H6 in the inner hole of the guide sleeve, and the surface roughness requirement is Ra 0.2, based on the left end dimension of millimeter as reference A, and the right end dimension of millimeter. It is necessary to ensure coaxiality error with reference A according to the structural characteristics and precision requirements of the guide pillar parts. The machining of the guide pillar parts requires processes such as turning, external cylindrical grinding, and grinding. Third, process analysis. Next, we will conduct a specific process analysis of the parts. First, selection of raw materials. From the figure, it can be seen that the maximum diameter of the guide pillar is 30, with small dimensional changes and relatively simple geometric shapes. Therefore, in single piece and small batch production, the raw materials can be directly cut with round bar material, which is more economical and convenient. Therefore, the raw material selected is 20 steel round bar material with a size of 35 × 150. Second, based on the structural characteristics and precision requirements of the guide pillar parts, according to the previous learning and table lookup, the machining process plan for the guide pillar is as follows: turning, external cylindrical grinding, and grinding. Third, the selection of positioning reference is based on the fact that the guide pillar is a rotating part and high precision dimensions need to be ensured for both the left and right sections of the shaft. 30 plus 0.041 or 0.028 and 30 or minus 0.016, as well as the coaxiality of the two sections of the shaft. When positioning the workpiece, the axis of the inner cylindrical surface of the design reference must coincide with the rotation axis of the machining tool spindle, so that the coaxiality of the outer cylindrical surface After machining can meet the requirements. During the machining process, the axis is used as the positioning reference, which is hypothetical and often needs to be reflected through the outer cylindrical surface and the center holes at both ends as a positioning reference. Fourth, there are usually 3 clamping methods for the processing of outer circles: 3-jaw chuck clamping, 1 clamp, 1 top clamping, and 2 tip clamping. Firstly, a 3-jaw chuck is used for clamping, and the end face and center hole are machined based on the rough outer cylindrical surface of the blank. Then, one end of the blank outer cylindrical surface is clamped onto the 3-jaw chuck. The other end is processed into an outer circle with the top support through the central hole. During precision machining, to ensure the coaxiality between the cylindrical axes, the center holes at both ends are used as a positioning reference, which conforms to the principles of reference uniformity and reference coincidence. Is also beneficial for easy clamping and improving productivity. Fifth, the formulation of the processing route based on the principle of course to find and prioritize main tasks over secondary ones, combined with the technical requirements of the guide pillar, can arrange the cutting sequence of the guide pillar as follows: round steel cutting, right end of the car, center hole drilled at the car end, outer circle, rounded corner, left end of the car, car end face, center hole drilled, outer circle, cone angle, rounded corner, back groove, etc. Grinding outer circle, rounded corner, cone angle, grinding outer circle. Sixth, the heat treatment process. According to the requirements of the guide pillar heat treatment, the surface carburizing and the quenching process should be arranged after the rough machining of the entire part and before grinding. Seventh, the arrangement of auxiliary processes includes inspection, deburring, cleaning, etc. of the workpiece in order to ensure the processing quality of the guide pillar parts and avoid the generation of waste products. The inspection process of the entire part should be centralized and decentralized after all processes are completed. The final determination is based on the principles of arranging the cutting sequence of the comprehensive guide pillar, arranging the heat treatment process, arranging the auxiliary process, and centralizing the process. The processing route of the guide pillar is as follows: round steel cutting, right end of the car, end face, drill, center hole, car, outer circle, car fillet, left end of the car, car end face, drill, center hole, car outer circle, car cone angle, fillet, car return groove, surface, carburizing, quenching, grinding the center holes, at both ends grinding the outer circle fillet, cone angle, grinding the outer circle, inspection and storage. Fifth, preparation of processing technology. The preparation of processing technology can be based on the drawing requirements of the guide pillar parts and the arrangement of the processing route, and non-standard imported single-piece production processing can be formulated, as shown in the table below. Firstly, material preparation: 20 steel round bar material with a diameter of 40 multiply 150 mm. Secondly, turning the end face, drilling the center hole, turning the outer circle of the car to size 31, rounding the end face of the car, turning the end face to ensure next dimension of 140, drilling the center hole, drilling the outer circle of the car to size 31, tool engagement, turning the 3 cone angle and rounded corner, turning the return groove of 8 multiply 0.5 to the drawing side. Thirdly, heat treatment: surface carbonizing layer thickness reaching 1.2 to 2.0 mm, quenching and tempering 58 to 62 HRC. Fourthly, filter, grind the center holes at both ends. Fifthly, grinding the outer circle. First clamp it with 2 tips, grind it to size with a diameter of 30 or to 0.016 and leave a grinding allowance of 0.02 mm. Grind it to size with a diameter of 30 plus 0.05 or plus 0.034. And leave a grinding allowance of 0.02 mm, and finally grind the rounded and tapered corners at both ends of the guide pillar. Sixth, grinding. First grind to the driving size with a diameter of 30 or to 0.016 to achieve a surface roughness of Ra 0.2 mm. And then grind to the drawing size with a diameter of 30 plus 0.05 or plus 0.034 to achieve a surface roughness of Ra 0.2 mm. Seventh, inspect and store. That's all for this lesson. See you next time, classmates.